Hi student, my name is Prof.Prakash Vasangar. Today we solve or we prove one theorem on a straight line for class 12 science. By write here the theorem, that is the statement of the theorem, and a statement is if theta is the acute angle between the lines represented by x square plus 2hxy plus by square equals to 0, then prove that tan theta is equals to mod 2 under root h square minus ab upon a plus b. In this theorem, one homogeneous equations of second degree in x and y is given. This is the homogeneous equations of second degree in x and y, that is ax square plus 2hxy plus by square equals to 0. And these equations represent pair of line passing through the origin. And here to show that the angle between the two lines represented by the given homogeneous equation is tan theta is equals to 2 under root h square minus ab upon a plus b. Where here, where theta is acute angle, that is theta line between 0 and 90 degree. So we prove this theorem. So first we write here the given homogeneous equation. The given homogeneous equation is ax square plus 2hxy plus by square equals to 0. This is the given homogeneous equations. And we know that these equations represent a pair of line passing through the origin. So suppose we assume that the one of the equations of the line represented by this equation is y is equals to mx. This equation do not contain the constant term. Therefore, the line represented by this equation passing through the origin. So we assume that here let y is equals to mx be the equation of one of the line represented by, this is the equation first. Here we assume that let y is equals to mx be the equation of one of the line represented by this equation. Then in these equations by put y is equals to mx. In these equations by put y is equals to mx. So we get here, therefore ax square plus 2hxy, but y is equals to mx, that is equation of one of the line represented by this equation, plus here b y square, that is mx whole square equals to 0. Therefore here ax square plus 2h x into x square plus b x square, which is equals to 0. Here b as it is mx square, that is m square x square equals to 0. Then from this here x square, here x square, here also x square. So x square take common. X square in bracket a plus 2h plus bm square, which is equals to 0. And therefore here bm square plus 2hm plus a equals to 0. And we observe these equations. This is a quadratic equation in m. bm square plus 2hm plus a equals to 0. This is of the type ax square plus, we know that the standard quadratic equation ax square plus bx plus c. So this is a quadratic equation in m. It has two roots, say m1 and m2. So we write here, this is a quadratic equation in m. This is a quadratic equation in m. It has two roots, say m1 and m2. It has two roots, say m1 and m2. Then from these equations we find here sum of the roots and product of the roots. So by now that sum of the roots, that is minus b by a, product of the roots c by a. So first we find here sum of the roots m1 plus m2 is equals to minus b by a. B means coefficient of middle term, that is 2h. A, that is the coefficient of first term. So minus 2h by b minus 2h by b. This is the sum of the roots. Then we find product of the roots m1 into m2 c by a. Here c, that is a upon b. So write here c by a upon b, constant term upon coefficient of first term. So this is the sum of the roots and this is the product of the roots. Then here we use one identity. We know that the identity, since m1 minus m2 whole square, which is equals to m1 plus m2 whole square minus 4 m1 into m2. We use this identity and find out m1 minus m2. Because here we prove that tan theta is equals to 2 under root h square minus ab upon a plus b. And we know that in the 11th standard, if theta is the acute angle between the lines, then tan theta is equals to mod m1 minus m2 upon 1 plus m1 into m2. So we find here first m1 minus m2. We find here m1 minus m2. For finding out m1 minus m2, we use this identity, that is m1 minus m2 whole square, which is equals to m1 plus m2 whole square minus 4 m1 into m2. Therefore here m1 minus m2 whole square equals to m1 plus m2, that is minus 2h by b whole square minus 4 m1 into m2 a by b. So write here a by b is equals to here minus 2 square, that is 4 h square upon b square minus, multiply here numerator and denominator by b. So 4ab upon b square. For equal denominator, here we multiply numerator and denominator by b. So we get minus 4ab upon b square. Therefore m1 minus m2 whole square, therefore m1 minus m2 whole square is equals to, here denominator is equal, so we subtract numerator. Write here denominator, that is b square. Subtract here numerator, and from numerator 4 take common, in bracket h square minus ab. 4 take common, in bracket h square minus ab. Then find out the square root. So we get m1 minus m2, which is equals to square root of 4, that is 2, under root h square minus ab upon b, and here write plus minus sign because we find here the square root. Next, we know that the formula for finding out the angle between the line tan theta is equals to mod m1 minus m2 upon 1 plus m1 into m2. We know this result in a 11th standard, that is in straight line. Therefore here tan theta which is equals to mod m1 minus m2, we write this, that is 2 under root h square minus ab upon b, this is m1 minus m2, upon 1 plus m1 into m2. We already find here m1 into m2, that is a by b. So we write here a by b. Therefore tan theta which is equals to mod 2 under root h square minus ab upon here b, here cross multiply. So we get here a plus b upon b, and this b get cancelled. Therefore here tan theta is equals to 2 under root h square minus ab upon a plus b, and this is the required proof. In this way, we prove the theorem, that is, if theta is the acute angle between the lines represented by the homogeneous equation, that is ax square plus 2hxy plus by square equals to 0, then we prove that here tan theta is equals to 2 under root h square minus ab upon a plus b. So dear student, if you like my video, please subscribe my channel and press on bell icon. Okay.